Welcome everyone. Thanks for joining us. Hopefully it's a reasonable hour of your time, not so much our time. And hopefully you can see a screen with Oracle on it, which means we're all working. We'll launch straight into it. I'm here, my name's Conor McDonald. I've got my Twitter profile up there. Please follow me on Twitter. That's where I generally put a lot of material about blog posts we're doing or what's coming up in the Oracle space in terms of SQL and analytics. As you can see from the map, I live in Perth, in Western Australia. So we won't keep the webcam on for too much longer because from Perth to US, as you know, it's all uphill, and bandwidth is a premium in Australia, so we'll try to make your slide content nice and smooth and seamless. And so all the webcam really adds is glare from my forehead, not much more, so we'll try to generally steer away from the webcams. I'm part of the developer advocate team. We're a team inside Oracle, and our sole focus really is just to hopefully make you guys more successful with Oracle. That's what we're designed to do. So in Australia, I've run some various seminars, and this webinar is another example of. We've realised that in the past, we've been really good at giving you some awesome software, and then perhaps not so great at then making sure you get the absolute most out of it. So I'm part of a team of 6, and our job is solely to make you more successful with Oracle. And that's one of the reasons we've resurrected the Ask Tom site, that Tom's taking a break. If you have any questions during today, I'd recommend you to actually ask them as Ask Tom questions, because then not only will the attendees do the answers, but also the whole broader Oracle community will get the answers as well. I also have a blog. Now, also coming from Australia and helping me out on today's webinar with a Q&A is Scott Wesley. So I'll hand over to Scott now.
Well, thank you, Conor. Well, I'm also from Perth. We're not in the same room at the moment, but well, what can we do? You want to flick the slide? Yeah, here I am. That's me. If you can't see me on the video, I tweet things at Swesley Perth. And you'll also find me at my blog, grassrootsoracle.com, which many of you may have encountered before. I've also, if you want to hop on the next slide, Con, done a video series on Apex. Apex is my thing at the moment, and I've also written a book recently on using jQuery with Apex. But yeah, if you have followed my Twitter feed, you'll notice I'm a science nerd with the Oracle game. So back to Conor, and I'll ask him a few questions about SQL analytics.
Okay, so I'm ditching my webcam, and Scott will be ditching his as well. That's the end of you having to watch our faces. The rest you can just focus on the slides, and hopefully you enjoy what's coming up. So today's topic is analytics. Now today's format is slightly different. It'll predominantly be slides, but the reality is, it's early in the morning. It's 6 a.m. our time, which is why we've been nicely juiced up on coffee. So hopefully it's interesting. But to make sure that I don't fall asleep, or Scott doesn't fall asleep, we're basically going to do a bit of to and fro with the slide content and hopefully ask some questions as well. So let's get started.
All right, that is my cue. I have some questions for Conor to get him rumbling on SQL analytics, and I'll try and hold him back because he runs pretty fast. So SQL analytics, I've learnt that a while ago, but what's the drive for other people to learn BI analytics? I've got some BI friends learning how to write SQL. What's in it for them?
Well, here's my motivation. The screen you see there is the world's most popular database. No, it's not Oracle. It's Excel, and that's just a tragic thing. But it is pretty much the reality out there. What happens nowadays is we have wonderful databases, but people drag that data out and they stick it in Excel, and they go, wow, that's really cool. I got to color code it and stuff like that. And the next thing you know, suddenly there's dozens of Excel spreadsheets in your organization, and very quickly after that, there's millions of Excel spreadsheets in your organization, stored on 150,000 different file servers in different versions of Excel, different formats. And they become the definitive source of information. So what happens is when management and IT says, look, the information is just all over the place, we need to rein it back in. You might go buy products like, like Oracle, and that's really cool because your data is once again centralized, it's backed up, it's secure, but you might think, well, the job is done. Guess what happens? 6 months later, Excel will be back, right? And once again, you've got just many Excel spreadsheets. And what happens is this. You'll have some old guy in your organization named Bob, right? And what he's done is he's built the world's most complicated Excel spreadsheet. Right? It's got every formula known to man. And the problem is, it becomes a thing that your entire upper executive structure in your company depends on. That's the thing that makes or breaks the company, the availability of that Excel spreadsheet. The problem is, Bob's an old guy. So eventually when Bob dies, what happens is your company just absolutely crashes because no one knows anymore what the budget forecast was or the actuals were or what the sales trends are because none of it's in your databases anymore. All it is in this incredible spreadsheet. I have this conjecture on every large corporation that you cannot kill Excel no matter what you do. Even if you go buy something like the Oracle Business Analytics or some third-party tool that gives you things like custom queries and ad hoc reports and quality solutions, it doesn't really matter. Somehow or some way, Excel just multiplies, breeds like rabbits through your organization. And that's generally a problem because your information gets just fragmented everywhere. You cannot kill Excel. Now the question is why? And this coming back to your question sort of about BI. The thing of Excel is it's not just a window of data. So if you look at the screen there, you can see it just looks like figures and columns and rows. But if you look underneath that, you can actually see that the beauty of Excel, as people will explain it to you, is that we have formulas and calculations, and you can do all sorts of cross-row and cross-column calculations. They want to do analysis with the data. We want to do moving averages, medians, variances, and stuff like that. And people say, I can't do that in SQL, and that's why I dragged it out of a good database and put it into Excel. And what's the alternative? Well, I don't want to go to the IT department and design up a reporting system and get it documented and sign it off and develop it and test it, implement it, because I know what that means. It means my requirements are going to be sorted out in 6 months' time. So that's the thing where people say, well, I'll rather do it in Excel. So for the BI professional, they think I use SQL to get data, but then to analyze the data, I use something like Excel. So there's one small problem with that. Once I get into things like a billion rows in a table, or millions and millions of rows, Excel doesn't really cut it. You're starting to do big, high-scale analysis. You need something powerful. You need to move that workload onto something like a database server. So what we want is one copy of the data, and it's easy to do. All you need to do is know how to use analytics. If they learn analytics, they can have all those Excel-like facilities they have without having to move the data from the server. And so that's why analytics is so important for BI.
It does sound pretty handy for BI, and I guess some ad hoc queries as well. But if I was a web developer using JavaScript or some of the tools that aren't Oracle, but talking to an Oracle database, would I still need to learn it? I mean, I could probably do any extra calculations I need to do on the browser, right?
Well, that's true, but it's funny. Knowledge of SQL is actually becoming really, really important nowadays. These are a couple of quotes that have been rolled out at OpenWorld over the last couple of years. They've come from people in Google and Facebook. That they all went off in these, NoSQL, various sort of data structures and data storage facilities, all which have their own place. Don't get me wrong, I'm not trying to bag them. But the language of accessing data has once again come back to being SQL. You really need to know SQL. It's become the sort of the de facto standard for accessing data, even in these more esoteric data stores that have come up. And let's face it, if you bought Oracle, you spent a pretty big investment. We don't give the software away for free, except in the Express Edition. So the reality is, you put a fair bit of investment in getting the absolute most out of Oracle, you may as well get advantage of it. And the problem with SQL is really nothing to do with SQL itself. The problem is that we suck at set theory. Now, that sounds a bit insulting to the audience, so let me flip that around. I'd prefer it this way. Set theory sucks. right? Because it's not our fault, right? These are the guys I blame, right? These are the guys that invented all this relational theory. And they came up with sentences like this: data is represented as mathematical n-area relations, etc., etc. When I read that, I don't get a light bulb moment. I just go, I have no idea what that means. Right? So what happens is we avoid set theory, and that's why people tend to steer away from things like SQL, and certainly web developers are like, I'll go with something I know, I'll go with something object-oriented or something like JavaScript, something. And as a result, we make work for ourselves. I'm a big fan of what's called the KISS principle, keeping it simple. Right? And I've done a series of videos called Keeping It Simple with SQL. If we do less work, if we can make the SQL do the work for us as opposed to getting SQL just get the data and then we have to write all the algorithms ourselves, we get the job done faster. And the beauty of that is, right, it's better for our business owners, and let's face it, as developers, right, if you get the job done faster, you have more time doing the things that interest you probably more than work. Right? For example, yeah, going down the pub and grabbing a beer. Analytics, in my view, equals more beer for developers, and surely that's a good one. So let me flip forward. So let me give you an example of that. Here is a modern set of application requirements. Right? I need the sequence in which everyone joined the company. Now, the reason I call it a modern set of application requirements is in the great world of Agile, that's what happens nowadays. We scribble something down in the yellow sticker, we call it iteration number 2, and voila, the rest is pretty much just said, okay, good luck, enjoy. So let's look at some sample data for that. Here's the classic emp table. So here's our data. We want to do the following. We want to add a column called the sequence in which you were hired. So you can see that Smith was hired first because he was hired in December 1980, and we knew that Adams was hired last, so he's the 14th. He was hired in 1983. Now using SQL, and this is why web developers have steered clear from this in the past, this is how you can do it in SQL. Right? I have no idea how that works, but it does. Right? It's an inline view and a correlated subselect, and as a JavaScript developer, I'm going, no way, I'm not doing that. I'll just do it post-processing once I get the data. Let's use the KISS principle. This is where analytics comes in and make it better. Right? Let's KISS and make it better. Using analytics, I don't need all that complexity. There's the syntax. I want to take everyone in order of hire date and assign them a rank. Just like that. Right? When I run that query, if we plug it in, there's the answer I had. So all of a sudden, I didn't have to drag all the data out. I didn't have to do sorting it on the client side, anything like that. I could simply add 40 characters of analytics SQL, and I've got my result. This is what I mean by getting stuff done faster without having to drag data around too much.
You make it sound so simple. I've taught a few people SQL in the past, and I've showed them code like this, and they get scared pretty quickly. I mean, there's an extra few brackets in there. There's an overstatement I've never seen before, and there's an order by in the column clause. What's going on here? You've simplified this explanation, haven't you?
I have, yeah. We've sort of jumped straight into the deep end, but let's take a step back. But one of the cool things with analytics is what you can see there is pretty much the entire syntax, right? It literally is, that's it. There's a function that might take some arguments. As you notice, the keyword is over. That's the big one. That means we're using analytics. And really there's 3 clauses, a partition, sorting, and windowing clause. And that's it. Okay, so in this case, what were we doing? We said we were ranking the rows. So we used a function called rank. Now let's look at these clauses individually. Partitioning is, do I want to segment the data in any way? And hopefully that animation will flow through over the interweb. So partitioning is, what if I wanted to group the data, say, by job? So I can see I partition the data up into color-coded chunks. In our case, we were doing a ranking across the whole table, so we didn't need any of that. So we didn't need a partitioning clause. Now, if I'm ranking anything, right, I need to know what the definition of ranking is. You know, am I ranking someone by a group of people by their weight or by their height? I need to know what the ranking is based on. So in our case, we were ranking on hire date. So that becomes the order by section, right? We are ordering by hire date. That defines how we're going to rank. We then have a thing called the windowing clause. The windowing clause is, if I'm looking at a particular row, and we'll talk about this later on, analytics says I'll be allowed to actually look across from that row a certain number of rows backwards or forwards, I can actually sort of jumping back and forward across the rows. We're not doing any of that. We're just doing a simple ranking across the whole table, so we don't need a window clause either. And there's where we ended up with our syntax as we saw before. Rank over order by hire date. So by building up the components as we go and eliminating the stuff we don't need, it actually becomes pretty easy to build analytic syntax.
Now, I've been paying attention. I saw in that data there that there's some duplicates. There's potential ties in this result set. How do you sort out who wins if there's a tie?
Okay, so we have different ranking schemes. So here's the classic sort of Olympic ceremony model. Okay, normally you have 1, 2, and 3. That's the winners of a race. But of course, what might happen is in the Olympics, if we have a tie for second, we don't have a third. We have first equals second, and someone doesn't get third. The person that comes next gets fourth. So we skip the number 3. And that's what rank does by default. So when ties occur, what rank does is it skips. So if I had a tie in the data, what would happen is rank would go 1, 2, 3, 3, and then the next rank would be 5. We actually don't get a fourth place. But we have control over that. You can actually use a different function called dense rank. And what that will do is go 1, 2, there's a 2 ties at third, then the next number is fourth. So you have total control over what you want to do with that. The other option is you can just have a contiguous sequence even if there are ties. If I use row number, it'll be 1, 2, 3, 4, 5, even if there's a tie. And we can see that with an example. I've put some data here where you've got Ward and Martin have a salary of $12.50 and Scott and Ford have a salary of $3,000. So if we're going to do row number order by salary, I'm ranking by salary this time, not by hire date, you can see that with row number, even though we have a tie at $12.50 for the salary, we get 4 and 5 and 12 and 13. Now, the obvious question is, why did Ward get a salary row number of 4 and Martin get 5? You know, who gets precedence? Well, in reality, no one gets precedence. What happens is this is indeterminate. Right? We don't really know unless we add something else to the order by to make it deterministic. So you can see there in the bold, I've basically added empno, which is the primary key. And what that would do is that controls, if there is a tie on salary, I'll use the employee number as, for example, to break the tie. But if I don't do that, then the results are non-deterministic. It really is at the whim of the sorting algorithm within Oracle as to how it chooses. So what we've got is we've got rank goes 1, 2, 3, 3, 5. Dense rank goes 1, 2, 3, 3, 4. And row number goes 1, 2, 3, 4, 5. So we've got plenty of options then when it comes to ranking.
And that's pretty good because we've got 3 specific ranking functions plus the ability to muck around with the order by clause, which gives us great flexibility. Is there any other specific ranking options that we get within analytics itself?
We do, and let's look at another requirement. We're up to iteration 12 now on our development curve. So I used a different sample data now. List the distribution of the top 50 movies at the $1.5 billion mark, which is just offensive in its own right. So here we have some fictitious data. I've got some gross sales from movies, and I've got a thing called percent rank. Right? This is another ranking function. And what that is, I'll times it by 100 such that we actually get some nice figures at the right, because normally it comes out between 0 and 1. But percent rank is effectively a standard statistical formula which really tells you the percentage, let's click on Furious 7 for example, the percentage of rows greater than the data. So what we've got is Furious 7 pulled in $1.5 billion. It is greater than 91% of the rest of the sample size, or 91.8%. Percent rank is actually a standard formula. It's this. It's the rank of the row minus 1 divided by the total number of rows minus 1. It's a standard statistical formula. We also have cumulative distribution, which looks very similar. All we do is we remove the minus 1s. So it's quite simply the rank of the row divided by the total number of rows. If I rerun that with cum_dist instead of percent rank, we get a very similar result. There's actually 50 rows in this table, so Furious 7 nice and evenly maps out to greater than 92% of all the other rows. So you've got percent rank and cumulative dist. One of the things that cumulative dist is really useful for is what we call plotting graphs. So what we used to do in high school is when we're trying to work out what percentage was greater than, say, where Furious 7 sat, we would draw a line across at the $1.5 billion mark, and we'd map down, and we'd say, okay, the movies less than $1.5 billion, comprised 92% of the sample, etc. So cumulative disk is the numerical version of the old graphing things we used to do at school. We also have entile. Now that term may not jump out as being familiar, but probably more familiar is things like quartiles and deciles and tertiles and octiles, in particular quartiles, which is where do I sit? So here's our same movies again. What we really want to do is, if I'm looking for, say, quartiles, I want to carve it up into 4 evenly sized chunks based on, say, the gross sales. How can I do that with analytics? Very simply. Entile 4 is the same as a quartile. Entile 10 would be a decile, etc., etc. So if I run that, it gives me an assigned quartile number to break the data up. So I could group by that or order by it, etc. So Independence Day being the lowest of the grossing gets quartile number 1. I go right up to Harry Potter, which is the highest of the grossing, that's quartile number 4. Okay, so in that case, that's how we work it. If we wanted to flip it around such that the highest grossing ones had quartile 1, we would simply order by gross sales descending. So there's lots of ranking options. We've got 6 at least, all for just doing functional ranking of data.
That's pretty cool. So we've explored the basic syntax. I saw partitioning in there, and what's that all about? I think people might see that and maybe think money, because partitioning in the database costs money. Is there any special table definitions we need to use it, or licensing considerations?
No, and it is one of those things where, yeah, people see, like, you know, partitioning, and the first thing is like, oh no, select from $V option. Oh no, I'm going to have to pay money. And yeah, we wouldn't do that too. Maybe. So iteration 13, let's look at another example. I need a report to list the highest 3 populated countries per continent. All right, and yeah, as I said, people go, oh, will I need partitioning? Will I need partitioning? Do I need to spend money? The answer is no. Partitioning in the analytic sense is purely about segmenting your data. The key phrases you'll be looking for as a developer or as a BI professional is things like per continent, or by department. And let's describe it with an example. What we really want to do is apply the same function, whether it's ranking or something else, to different subsets of the data. And different subsets means different partitions in this case. So let's look at some countries. And this time they're broken out by continent and by name, and we've got their population there. What we really want to do is rank them, as we saw the requirement, the top 3 by continent. Now what I could do is do it like this. Let's go get the first 3 by Africa, then run another query where the continent is Oceania, and then run another query where the continent is Europe, and so forth for each of the different continents. That's where the partition clause comes in. Right? What I want to do is partition the data and then apply my function, whether it be ranking or anything like that. So let's look at the example I've got. Partition the data by continent first, and then order by population and assign a row number. So now what we've got is, you can see, rather than the row number just going 1 through 20, it goes 1, 2, 3 for Africa, 1, 2, 3 for Asia, 1, 2, 3 for Europe, and so forth. So effectively, I'm breaking the data up into chunks and then applying my analytic function.
That's pretty cool. I like that. So there's a lot of functional options that we've seen here about ordering and ranking and things like that. But what about the aggregation? We've been promising aggregation tools and stats for the BI people. Where is it? What can we do?
Okay. Aggregation, let's talk about that. Right. Let's, once again, I'm trying to put as many examples in here as we can today, because then when you get the slides, by the way, I should say the slides will be available on Ask Tom eventually after the session, and also I'll be getting them to the ODTUG people, so you can get them from there as well. So we'll bang on with a lot of examples. Iteration 21, I need departmental salaries running total by employee name, and obviously total suggests aggregation. So here's our data, back to our employee table again. Once again, let's build up an analytic function using just breaking it down into components. So the first thing is, I'm doing it by department, so I need to partition by department number, and we just learned the partitioning clause. I'm doing it by employee name because I'm saying running total by name. What am I doing? I'm summing up some data. That's what a total is. And what am I summing up? I'm summing up the salary. Do I need a windowing clause? Not yet. Okay, we're not doing anything like that. So let's plug that function we just built up into our query and see what we get. There's our running total. Let's walk through it row by row. So the first row we hit in department 10 is Clark the manager. His salary is 2,450, so the running total is logically 2,450. We move to the next row, and the running total is 7,450 because we've got Clark and King, and then we have Clark, King, and Miller, and we have 8,750. Now, when we move on to the next row, the total resets. Why does it reset? Because we're partitioning by department number. So we've hit a new department number 20, and so our running total starts again. But that's how we do aggregation, nice and simply, right? It's simply a standard sum, just like your normal stuff, sum, average, min, max, etc. But the over word makes an analytic function. A word of caution, very, very important. That result there looks reasonable simply because I've partitioned by department number and ordered by e-name in the analytic, and I've ordered also the whole result by the department number and e-name. And so the running total actually matches sort of the nice layout of the actual query. I don't have to do that. I could actually do a sum of salary. I can get a running total by department number ordered by employee name, but my results can be ordered however I like. I could order by department number and hire date, right? Because they're different, what happens is the actual running total looks a bit strange. If we look down at that one there, 4,450, it doesn't seem to match up because we've gone 9,400, 6,650. You know, the running total seems to be going down. The running total is actually correct. It's just the actual outcome, the actual output result has been sorted differently. That 4,450 is correctly the sum of 1,600 and 2,850, which is Allen and Blake from Department 30. So the totals are actually correct. It's just that the output looks a bit counterintuitive because I haven't ordered the result set by the same as I ordered by my analytic. You don't have to. Just be aware that the data looks a bit strange, but it is actually still correct. There's a lot of power in analytics. In one query, for example, I could do sum salary over and just empty brackets, which is over the entire lot. I could do sum salary by department number, sum salary by department and job number. I can do all these totals and aggregation all in one query. It's very easy to do just with multiple analytic functions.
And it does seem easy. I mean, you basically changed the rank keyword to a sum, and now you're doing totals, which is great. But we've just gone from a running total, and here I see the total cell, all the values are the same, and the others are broken up a little bit there by partition. What's the go here? What am I looking at?
Okay, that comes down to two incredibly important points in terms of grasping the concept of analytics. Number one, and we'll come back to your question just in a second, but I'll touch on this point first. Think about a conventional aggregation. Normally when you do like select department number, sum, cell, group by department number, there's 14 rows in the employee table, but I get 3 rows in the result. What I'm doing is I generally get less rows in the result than the raw data when I do a conventional aggregation. For an analytic, it's different. For an analytic, we are calculating aggregates, we are aggregating the data, but we are not aggregating the actual result. So in this case, I've got the same result there, the same numbers, but I don't actually reduce the number of rows. I keep the original rows in the table plus some aggregated information that came out of the analytic. I've aggregated the data, not the result. So that's key point number one. Just because we're doing aggregations, we still have access to the raw data at a row level. Key point number two, there are actually 2 kinds of aggregation when it comes to analytics. The 2 kinds are reporting aggregation, and the first one that is the same aggregate for each row in a partition, right? And there's a good example, sum salary over department, partition by department number. You can see that I've got all 14 rows of the employee table there, but because I'm doing simply a sum partition by department number, I get the same summation for each row for each same department. So for department 10, the total salary was 8,750, independent of what row I'm currently looking at. For department 20, it was 10875, etc. I get the same row, the same information for each row in the partition. That's a reporting aggregate. The other kind is what we call windowing aggregation, and we're sort of leading into that last window clause now. A windowing aggregation is the aggregate can change in each row in the partition. And this is where the windowing clause comes in. It defines how broadly an aggregating function applies. Let's look at an example. We have a beautiful picture of the oceans there. So this is our next requirement. I need a running total of total ocean coverage across the world, largest to smallest. So here's our sample data, some oceans of the world. We're going to build up our analytic function once again. We're doing a sum of the square kilometers. We're aware that a total generally means sum. We're not partitioning by anything. We're doing across all the data we've got. We're sorting it by the square kilometres, the size of the ocean. Here's our first look at the windowing clause, and this is probably the toughest one to get your head around. Rows between unbounded preceding and current row. Let's put that in to our SQL, and then we'll walk through what it actually means. So there's our analytic function. Here's our total. So what we're saying is, let's start with row number 1, Pacific Ocean. We've got 1.5, what's that, million? 1.5 billion, 150 million square kilometres, or 1.5 billion square kilometres. That's a lot of kilometres. The running total is the same. Why is that? Because I start with the current row, that's what rows between unbounded preceding and current row means, and go back as many rows as I can, ordered by square kilometres, descending. So how many rows can I go from the Pacific Ocean? None. It is the only row. It's the highest row. I move down to the Atlantic Ocean. I go from the current row, which is Atlantic Ocean, as far backwards, ordered by square kilometres descending, which takes me back to Pacific Ocean. Why as far back? Because I'm going unbounded preceding. Go backwards as far as I can. Indian Ocean, same thing. Go back as far as I can, through Atlantic, through Pacific. By the time I get to the very bottom, the Baltic Sea, I'm saying from my current row, which is the Baltic Sea, walk backwards through all the data, ordered by square kilometres descending, an unbounded amount, as far as I possibly can proceed, which takes me all the way back to Pacific Ocean, and the current row, which is the Baltic Sea. So the windowing clause is telling me how far I'm going to look across rows.
I can see the potential there. That's an interesting example with a cumulative amount, but I'm looking at my own window, seeing the sunrise here, and I got a bit distracted. Is there ways you can explain windowing in another way? I think the potential here can be explained even further with a few different descriptions of what windowing can actually do.
Let's bang into another example. Let's do the same thing with our ocean data. This time, rather than going unbounded, we're just going to look at a few rows, right? And by type of water region. Remember I said when you see the word per or by, it normally means partitioning. So let's build up our function again. We're doing sum of square kilometres, partitioned by ocean type this time, because we're saying by type of ocean. Once again, by the size of the ocean. Our windowing clause, one preceding, one following. Now let's look at what happens when we actually apply that to the data. We start at the Pacific Ocean. The first row there, we're saying from the current row, let's look one row backwards. Now there is no row that precedes the Pacific Ocean. It's the highest row in terms of square kilometres, so we get nothing, right? But we can look one row forward as well. So rows between one preceding and one following effectively means from my current row, look one backwards, look one forwards. How do we define backwards and forwards? It's the order by square kilometres descending. So we look one row forward, one row backwards, we get 2.3 billion. As I move on to the next row, we can see Atlantic Ocean looks one backwards, Pacific Ocean looks one forward, Indian Ocean, etc. Right? As we walk through, we're looking one row backwards, one row forwards. We have a lot of flexibility when it comes to how many rows we want to look backwards and forwards just by using the windowing clause. Nice and easy. And one thing I should say is you can see we've stopped there at the Arctic Ocean because we partition by type. So I can look one row backwards into the Southern Ocean. I can't look one row forwards to the Mediterranean because it's a different type of ocean, different type of waterway. So that's the partitioning clause coming into play there.
So you're going from one row to the next and seeing across a number of other rows. Do we have other options? Can we maybe do things by value?
Yes, we can. That's a very good point. The windows you've seen so far are defined by rows. Okay, so for example, I've got the Arctic Ocean. I can look forward, I can look backwards 3 rows, or I can look forwards 2 rows. I don't have to look at an even number of rows either side. I can do whatever I want. The problem is that gives us rows between 3 preceding and 2 following. The problem is often what we want to do is actually define a window by the data itself, not the number of rows in our table. So we might say, I'm on the Arctic Ocean. I want a window that is defined by 20 million square kilometres either side. So I want to go up to a maximum of, say, 34 million square kilometres, down to 0 because 14 is less than 20. So this is what I want to cover. I want a window that defines all the rows up to 34 million, which is 14 plus 20 million, and all the rows down to effectively 0. So the number of rows there is actually indeterminate because it depends on the actual piece of data I'm currently on. we can do it. There's a thing called range window option as opposed to rows. And that's the syntax I always use there, range between 20 million preceding and 20 million following. So we can do range as well. So let's look at an example of that. If I want to do a 6-month moving average of tweets per day using some Twitter data, that's not my tweets per day, this is global tweets per day. We're up to iteration 55. So I found some information on the internet about how many millions of tweets get done per day. Back in 2006, it was very, very little. But last year, 470 million tweets per day. That's a lot of tweeting. So that's our sample data. We can't use the rows between option here in our window because if you see there's some sparse data. So if I simply say I want to look one row backwards from December, I don't get November, I get October, and that would break my 6-month moving average rule. I only want to look back 6 months, not 6 rows, for example. So rows isn't going to cut it, we have to use range. So let's build up our analytic again. We're doing an average of tweet millions, we're not partitioning, we're ordering it by date, and our window clause, it wants to be 6 months. So we're doing range between an interval that's 6 months large, preceding, and the current row. That is a 6-month moving average. We plug it into our data, and there's our moving average. Now, moving averages are one of those things that are so common in Excel because everyone says, oh, I can't do that, in SQL. It's really, really easy to do once you start using things like the window clause. As you can see, January 6th, the moving average was 0. In fact, it stays 0 for the first few iterations. You can see that by the time we get to January 15, we're actually looking back to the 1st of September, that's 14. So we actually spanned 4 rows there, right, to get our 6-month moving average. 4 rows again. By the time we get down to the bottom, 1st of December, we went back 5 rows because we had some sparse data. So the number of rows varies, but the range is fixed at 6 months.
Wow, it's just ongoing how many different options and things that we have for SQL analytics. So if they can span any number of rows here, how do I know where the data starts and ends? Do I have options to give me that sort of information as well?
We do. We have some extra analytic functions called first value and last value. So let's get into another iteration showing me life expectancy throughout the UK compared to 5 years either side. So here's some raw data. We've got information on life expectancy in the UK going all the way back to 1543 up to 2010. So building up our function, we're doing first value of age, no partitioning clause, ordering it by the year, and we're seeing 5 years preceding, 5 years following. Let's plug it into our SQL and see what we get. There's our results. What does that actually mean? Let's pick a random row. 2004, right? The first value is that a window is 5 years either side. So there's our window. We pick the value from the start of the window. That's what first value says, and that becomes our first value. We pick the value from the last value. So the last value is the other end of the window. So 2004 again, we go forward 5 years to 2009. That gives me 80.1, and that becomes the value for our last value. So it's very easy to pick out boundary values from the window, even though we don't know which actual particular row it is. We can actually extend it. There's also nth value. So if you want to get the second lowest value in the window or the third highest value, you can do that as well using nth value. Windows can also be dynamic. I can have something like, give me the total sales from the previous business day. And what that would mean is, let's say we don't work on the weekend. So on Tuesday, I want all the sales since Monday. On Wednesday, all the sales since Tuesday. But on Sunday, I didn't work on Saturday, so I want all the sales from Friday. And same on Monday, I want all the sales from Friday because I didn't do a business close up on the weekend. I could create a function that actually says, this is the number of days I'm going to look back depending on the incoming date. So for Sunday, look back 2 days, Monday, look back 3 days, otherwise we look back 1 day. I can actually put that function into my window clause. So the actual range dynamically changes for every single row that comes in. It's very, very powerful.
Excuse me. So back to that question about running totals. Some of the examples that we saw were cumulative, and then you gave me some that had all the same value because of that well-explained notion of we're still seeing all the data and we get to see the final aggregation for all those rows. But in those examples, we didn't have any windowing clauses. So how did that come about?
Okay, I'm glad you asked that because someone put in the chat window that's pretty much the same thing. Sometimes we've got a cumulative, sometimes we have a total. Here's our running total example again. It's a windowing aggregate. You can see that the row changes, the running total changes for every single row. But there's no window clause. Let me flip back. It's just partition by department number, order by enum. There's no window clause. How come we got a windowing aggregate? Here's the rule. If this is an aggregate function, sum, min, max, etc., and you have an order by clause in the sorting clause, then you get a windowing clause automatically, and this is the default, range between unbounded preceding and current row. Now you might say, why is that the case? Well, if I just had a sum and a partition by, or even just a sum, then the moment I added the order clause, the moment I add a sorting clause, it really doesn't add anything. If I want the sum of all the salaries per department, it doesn't matter what order I take the rows in. The sum of all the salaries in Department 10 is the same no matter which order I take them. So the fact that I added an order by, Oracle, we're interpreting, we're saying, you obviously wanted to use the data in a particular order. That would only make sense if you're doing it in a windowing fashion, because otherwise you wouldn't have had the order by clause at all. You just wanted the simple the reporting aggregation. So if you don't specify a windowing clause, but you did have a sorting clause, you get a windowing clause automatically. And that's why you see those running totals, even though there was no windowing clause. We actually inserted one for you.
Sorry, I'm fighting my small windows here. So with the aggregate across rows, in Excel, this wonderful database that everyone uses, we used to have this formula that we could just refer to the previous row if you wanted to do comparisons or check the differences between rows. Can we do this cross-row calculation with analytics as well?
We can indeed. And the hint here is the over. Obviously, over sort of suggests that, you know, I want to be able to look across rows, and that's sort of what windowing clauses do. They look now from a current row, they look across rows. We actually have explicit access to that using the lag and lead functions. So, for example, if I say, get me the lag salary 1 defined by hire date, right? I'll draw some little arrows there to help you out. As I move on to Smith, right, defined by hire date, there's no one hired before Smith, so no one has a salary, a previous hiree salary. If I look at Alan, the person hired before Alan was Smith based on hire date. We can see line 4 in this equal. So the previous person hired was Alan, and we can get the value of the salary for that previous hire. So effectively, I'm looking one row back based on hire date to look up that person's salary. So you can see we have that nice sort of cross-row ability, just like we would in Excel.
So really, this is all about statistical analysis, isn't it? That's what we can do with analytics.
Yes and no. There's amazing statistical analysis you can do, but the cool thing with analytics is once you sort of can break out of that mindset of this is really just for the BI person, once you start using your imagination, you can apply analytics to all sorts of problems. It's not just BI and stats, etc. A lot of the classical problems that we normally had to use a lot of our own code for become simple. For example, show me the median, right? The median salary for each department. Yeah, people say, well, I don't need analytics, but I can do that in JavaScript. Yeah, there's a JavaScript function for doing median, right? Here's the problem, right? Sorry, let me scroll back once, if I can. Previous. Here's our median function, right? It's really easy to write, right? It's 4 lines of code, or I can simply get the one from maths.js. Versus writing a median in SQL, right? No web developer or any developer wants to write that because for a start, it's impossible to understand, and the other thing is, who's going to maintain it? You know, what happens when we want to change it? Here's the problem with doing it with your own code. That keyword there, values.sort, right? It seems so innocent. What it means is I've just dragged 1,000,000 rows out of my database server, and now I'm sorting them somewhere. Now it's either on an app server, which probably doesn't want to be sorting 1 billion rows, or it's on your client web page. It definitely doesn't want to be sorting 1 billion rows. To find the median, you've got to sort the data. The best place to sort a lot of data is on something that holds a lot of data really well, which is a database server. And this is how you can do it. Median is actually an analytic function, even though there's no over keyword there. But it's so easy, just median, very simple. Some of the other classical problems, removing duplicates from the data. It's got nothing to do with statistical analysis, which really means when someone says remove the duplicates, what they're really saying is your data is crap and it has to be fixed ASAP. How do we do it? Here's our bad employee table. I've highlighted some bad rows because Alan and Smith are duplicated and they weren't meant to be. So using an analytic, partition it by the logical primary key of employee number, order it by row ID. Guess what? Each of the duplicates now has a row number of 2 assigned to it. So I simply take that query, bang it into a subquery, and that's how I delete the duplicates. Once again, using analytics in a non-analytic function, so to speak. For example, find the 5 highest salaries for each department. Right? Nice and simple. Right? Do a ranking, partition by department number, order them by salaries, and then simply pick out those where the ranking is less than or equal to 5. Right? Grouping data into consecutive ranges. This one is totally non-analytics at all. Here I have my sample data. Right? What I want to do is look for contiguous sets. So 2, 3, 4 should become 2-4. 7 and 8, then there's a gap. So then 12, 13, then there's a gap. 15 to 17, 19 to 20. I'm going to fly through this example, but it's really an example of showing you how we can start building up lots of analytic functions to solve requirements such as this. So the first thing I'm going to do is use lag, right? And lag starts to give me a hint of every time the lag is not the same as 1. So if I go back a bit, if it's 3 to 2, there's a difference of 1, it's consecutive. If it's 7 to 4, it's not consecutive. So I'm starting to work up some logic as to where the gaps might be. I then put a case statement around it, and now I've got just those ones. You can start to see I'm building up those ranges that I'm interested in. I put a max around that, and I've simply collapsed all the data in. So there's my ranges I'm after, but I've got some redundant data as well. Do a group by, and there's my result. Now, don't get me wrong, we went through that at light speed, right? But it's not really designed to explore that particular solution. It's really showing how we can use analytics and inline views to build up solutions to our problems using sort of a piecemeal approach. In-list processing, this one's the classic, right? This is the kind of thing you get. We got hacked. Why did we get hacked? Because what happens is people build code like this. On the web page, you can type in up to 3 account numbers, and then somewhere in the code, someone simply said, simply append those 3 numbers into a string, right, and run that string. And what happens is your system will crash very, very soon because someone's going to type in this for their account numbers. They're going to end your string and then put drop table accounts cascade constraints purge, and guess what? You don't have an accounts table anymore because you got SQL injected, right? That's one of the disasters of building up literal strings of SQL. The problem is you can't just type in 1, 2, 3, 4, 5, 6, 7, 8, 9 into a bind variable. You get invalid number. Oracle doesn't treat it as 3 numbers. It treats it as 1 number with commas, which is illegal. Using some analytics, we can convert that string into a set of rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Using some lead and some loc and a little bit of other stuff like that, we've got 3 rows now, 1, 2, 3, 4, 5, 6, 7, 8, 9 as rows. Once it's rows, we can treat it as a table. The very last line there, we're account number in, select from our list of rows. What I've got now is a non-SQL injectable web page. That's how we solve these problems. We can do the opposite. There's a great function called list tag, because this is a classical problem. The classical problem is I've got all the data that looks like this, 1 row for every piece of data, which is how relational databases work. But this is what I want. I want for Department 10, all the names listed out to the right. Department 20, all the names listed out to the right, etc. Easy to do with analytics, right? You don't have to write any pure SQL code or anything like that, or C code. You simply do list tag, and the great thing is it reads much like the actual requirement. I want to aggregate a list of employee names, separated by commas, within the group defined by the group by, which is department number. In which order should I build the string? I'm going to build it in order of employee number. So the actual function almost reads like the requirement, which is really, really cool. Hopefully that's a little taster of some of the things you can do with analytics that aren't really statistical.
And that is a nice taster. I mean, this tag is a nice, simple example of something that we need to do all the time. And there's functions that you have listed that I do use all the time. Row number is one of my favourites. And then you've got some extreme examples that maybe require a bit more skill level. Are there any other goodies out there, nice, simple nuggets of goodness that we can use?
Yes, there's a thing called the keep extension, which is, I know I've said every analytic has the keyword over, but we've extended this and probably best described with an example. Let's look at the lowest salary for each department. That's a standard group by, no analytics there. I want the minimum salary group by department number. And of course what will happen is your boss will say, oh, I need to know who has that salary as well. Now if you just plug the empno in there, you get an error because you can't have that column selected and not group by. But if you put no in the group by, then of course you've actually changed the problem. You don't get the minimum salary by department number. Keep lets you do that. What keep says is, as I'm picking up the minimum salary, I want to pick up the minimum employee number sort of along for the ride. And the keep syntax is quite weird, but what I'm saying is get the employee number, keep the one that has the lowest salary, and dense ranked first, which means the lowest, and what am I ranking? I'm ranking by salary. So in that case, I satisfy the requirement using the keep keyword. I'm saying employee 739 is the guy that has that lowest salary of 1,300 in Department 10. So the keep syntax lets you pick up information at the extremes of aggregation and you sort of drag them along from the ride, and that's why I like the term keep. There's inverse analytics. Remember we did cumulative distribution, right, which looked a bit like this, right? Someone might say, what is the 60th percentile salary? So what I'm saying is when I look at the cumulative distribution, it's either, well, we might say it's Clark because he's the first person over 60, or you might say it's the average of Alan and Clark because they sort of span 60th percentile either side. We might choose that. Well, we've got functions to do that. We've got percentile discrete and percentile contiguous. So I can actually get what are the salaries at the 60th percentile, either discrete, which is the first person above 60, or continuous, which is the average of the two that span 60. So that's like inverse analytics. I've got hypothetical analytics. I can say, rather than where does, give me the ranking of all the salaries, I can say, if I was paid $3,000, I have no row that was matched that is salary $3,000. I can say, if I was paid $3,000, where would I actually rank? And rank 3,000 within group order by salary. So using the within group as opposed to over says, this is where I would rank in the department if I was paid $3,000, as opposed to I need to have some data of 3,000 and then I can rank it. So this is a hypothetical analytic. There's also ratio to report, which is a nice, simple, really common requirement in Excel, which is show me the percentage that each row consists of compared to all the other rows. So here's our iteration 107. Report the salary percentage breakdown across all employees. It's really easy to do. A ratio to report salary, in this case, over the entire set. So you can see that Ward's salary of $12.50 contributes 4.69% of the entire salaries. Blake's consists of 10.70%, etc. That's a super common requirement that we use in Excel, the percentage over the total.
This is almost as if SQL Analytics is what can't you do. So are there any limitations and gotchas we need to think about? I know I've been playing with ListAg recently and I've encountered the 4,000 character limit. And I think there's an issue with lag in looking in the past. So what do we need to consider? What do we need to look out for?
Okay, that's a very good point. For a start, what Scott's mentioning there is he's got an excellent blog post on this in terms of ListAg at the moment, out of the box, ListAg lets you build a string that's up to 4,000 characters long, and then you'll start getting errors. There are some workarounds to actually make the ListAg function return a clog, which obviously gives you an almost arbitrary length. So go see Scott's blog posts. That's the link there. You obviously
I can just thank Carsten for that too. That was me pointing out a non-English solution to that particular problem. So not all me there.
Oh, come on, Scott, take the credit. Couple of limitations. Null. Right. Let's rank the size of the moons: planets Mars, Venus, Pluto, Metrium, Neptune. So here's my query. We've seen row number before. I'm ordering it by the radius of the moons of the various planets. When I do that, I can see Venus and Mercury come out as number one. Oops, let me scroll back one. Venus and Mercury have come back as number one. There's a problem with that, right? And the problem is, the reason they came out as number one is because they don't have any moons, right? So when I did an outer join to the moons table, they came back as null. My radius was null. By default, right, nulls are ranked first. So Venus and Mercury came out first, even though they didn't have a moon. We didn't probably want that. As per normal order by, and a lot of people don't know this in the normal order by, you can choose. You can actually add nulls first or nulls last. You can choose how you want to order things by. So you can see in the analytic there, I've made a slight adjustment. I've said I want nulls to be ordered last, not first. And now Mercury and Venus appear at the bottom of the screen, not at the top. And I got the data I actually really wanted, which was Neptune has pretty much the biggest moon. Radius nulls last. Another potential ambiguity when it comes to nulls. We all know that null is special, right? What I mean by special is nothing equals null. If I do select star from due where null equals null, I get no rows. But if I say not equals null, I get no rows. Null doesn't equal anything ever. Except when it comes to analytics, unfortunately, when it comes to ranking. When we rank nulls, right, you can see that two nulls will be given the same rank, 1 and 1. Ranks, right, nulls are ranked equally when it comes to analytics. Just keep that in mind. The only other limitation that, well, it's not really a limitation, it's something to be aware of, is predicates. Let's look at an example. If I'm doing the 3 largest moons restricted to Earth, Mars, and Saturn, there's a potential ambiguity even in that question. Here is Earth, Mars, and Saturn, and here's our predicate. If I say where planet name is Earth, Mars, and Saturn, and the row number ordered by radius descending is greater than 3, I'm looking for the 3 biggest planets, 3 biggest moons. Do I restrict it to the 3 planets first, and then do the row number? Or do I get the row number across all the planets first, and then see which ones are Earth, Mars, and Saturn? There's an ambiguity as to which predicate I should apply first, because we actually give a different result. If I did the row number first and said I want the biggest moons, then Jupiter has got the biggest moons by a long way. Right? So what's going to happen is, which one am I actually going to be doing first? And the way we solve that, right, is we always apply the normal predicates first, and also we make sure an analytic is not allowed to be a predicate to resolve that ambiguity. It adds a bit of clarity. If I try and use an analytic in a where clause, you'll actually get window functions and not allowed here. You actually can't do it. You have to use an inline view, which adds some clarity. So here's what we do. The first thing we do is we say, okay, go get the row number as a column in the result, and we apply our where predicates first, planet name, Earth, Mars, Saturn. So we have to get the results first after applying our predicates, then we can wrap it in an inline view. And that adds that bit of clarity and shows that the analytic will be calculated based on the where clause, and then we can apply where clauses additionally to the results of the analytic, if that makes sense.
I find the SQL example here a classic demonstration of how I use analytics all the time, and the flexibility that it provides as well, of having that choice of either ranking it first and then having it as an inline view, or doing the opposite. So in regard to documentation, I like the Oracle documentation. I know there's descriptions there on what an analytical function looks like and what the syntax is, but we've just seen so many case studies of how it's used. Is there anything in the documentation that sort of expands how you can use these analytics, not just functionally what the statement looks like?
Man, I wish you hadn't asked that question. But anyway, sometimes we at Oracle, we get it wrong, right? We don't do so well. If you fire up the documentation, right, and look up this section called Developer Essentials, all the things that you need, for application development, whether it be the left-hand side of the screen or the right-hand side, we have all these great things you should go at, the SQL Language Guide, Pure SQL Language Guide, whatever. One thing we didn't put on there is the Data Warehousing Guide, right? And sadly, tucked away down in Chapter 21, we have an awesome amount of documentation on all the analytic functions. Now, I don't know about you, but as a general rule, I don't open up the Data Warehousing Guide Chapter 21 when I'm thinking, oh, I need some information on SQL. But unfortunately, that's where we've got it. So I can't stress enough, go have a read of the Warehousing Guide. That's where all the good examples are for analytics. And even then, I'll tell you a funny story because we were just about out of time. I was working at a client site recently, and I went to look at the documentation. I have to admit I wasn't looking for the Data Warehousing Guide. But when I got there, I got this. This website is blocked. I couldn't actually access the Oracle documentation, right, from this client site. And I got an email from the administrator saying, the reason you're not allowed to look at the Oracle documentation, it's become apparent that many of the application development people at this company, they're accessing this site during regular hours, consuming lots of internet bandwidth. So there you go. Sometimes, even when people are trying to do the right thing and actually read the docs, something will get in the way.
In that quick screenshot there in the documentation, there was other things on SQL analysis. Is there anything other cool stuff in that chapter that on top of what analytics provides? There's a thing called partition data join, but I am just mindful of the time as well. We'll go maybe just a couple of minutes over. We'll see. We might fly through this very fast. So partition data join.
Let's say we've got a room of bookings, people booking a meeting room, and we've got a number of hours that those meeting rooms are available to be used for, from 8 AM through to 16 PM. A standard outer join would show me the bookings by hour. So if I join the hours table to the bookings table, I get at 8 AM, Pete's using room 2, 9 AM, John's using room 1, etc. What if I want that same information broken up by room, right, so for each particular room? Then there's this syntax. This has actually been around since Oracle 9. If I do partition by and then an outer join, I actually get the same amount of data, same amount of rooms, 8 through 6, same hours of the day, 8 AM to 6 PM, 16 PM, 1600, for each room, room 1 and room 2. And it doesn't matter how many different rooms I got there. Effectively, it's done a select distinct of the rooms in there, and I get information per room. A couple other ones, width bucket. Width bucket simply says, I want to carve up some data into nice, evenly sized buckets. So if I'm looking at, for example, the object ID, and I've said the width bucket from 1,000 to 90,000 and 10 buckets, it breaks up into 1 to the number of buckets, 1 to 10, starting at 1,000, ending at 90,000. Anything below 1,000 gets bucket 0, anything above 90,000 gets bucket number 11, which is 10 plus 1. So width bucket's useful. In terms of limiting SQL rows, that's the new feature. This is in the data warehousing guide. I'm not sure why, but it's a 12C feature. The fetch first 5 rows only. That is for another day because we've got a lot we could talk about. Now, what I'm going to do is I'm just going to jump forward a slide, Scott. Hold on. Okay. I'm going to have to cut you off, Scott, because we're just about out of time, right? But I will sort of finish off with one last thing. A lot of people say it's not really about analytics, right? That when I'm analyzing the data, it's not the analysis that's important. What I'm doing is I'm actually looking for trends and patterns in the data, right? And in 12C, once again, in this documentation, we have a thing called pattern matching, a whole new chapter on pattern matching, right? It's an awesome syntax, right? And incredibly powerful. Much like analytics has become this incredibly powerful language for data analysis, the 12C pattern matching stuff has become an incredible language for doing trend analysis and looking for patterns in the data. Once again, that's something for another day. We'll hopefully have another webinar at some stage to cover that because it is just an amazing piece of syntax. So I'm going to wrap it up because it's 7:02. We run 2 minutes over. Thanks for everyone for staying on. We've spoken about analytics today. I hope you found it really, really useful, and I hope you've liked the format where Scott and I have hopefully had a bit of to and fro. What we're hoping to do is, Scott is one of the best Apex guys out there in the Oracle community, so hopefully I'll get a chance to do the same thing with Scott in reverse soon. I'm an Apex newbie, so we'll get Scott on through some Apex expertise, and I can be the guy that's asking him what the hell it's all about, because I like Apex. It's one of the wonderful technologies floating around there, but I'm not particularly skilled in it. So I'm going to wrap it up. We're going to pop our webcams back on very briefly, hopefully not destroy all the bandwidth. So I'm wearing my KISS principle, keep it simple with SQL. I'll hand over to Scott to say goodbye from his side, and then I'll wrap it up.
I just realised I'm wearing the same shirt as in that picture. Yeah, it's been a great interview, and I look forward to doing something in reverse in the near future. Thanks very much, Connor.
Thanks, Scott. Thank you, everyone, for attending. I hope you had a wonderful time. And the slides will be available on the Ask Tom site. If you have any questions, please feel free to ask them on the Ask